Welcome to our math class. Today, the area of discussion is measurement. Our strand here is measurement. Uh, we have an area of discussion as measurement. And under measurement, I want us to talk about length. Measurement is quite huge. So I want us to talk about length. Right. I believe you have a book. Make sure you have a book and a pen, at least a place to write and a pen. This is important in math class. Anytime you have a class, ensure that you are having a place to write so that we can make our lesson more productive. Now, without taking much time, we will be having an example in each and every area of learning. So I'll be defining a number of terms here. We know what they are. Then I give an example. If there is a formula, then I'll be guiding us. In case of any concern, please feel free to inbox me. Feel free to tell me the area of concern, or if there is any question or even a comment, please, I'll be glad to interact with you in the comment section. Right. The first thing that I want us to have a look at is perimeter. So this is the first thing that I want us to check, perimeter. And what is perimeter? Perimeter, perimeter the distance is the around distance around a figure. Perimeter is simply distance around a figure, or in other words, is the total length around a figure, is the total length around a figure. So anytime we talk about perimeter, it is simply the distance around a figure or total length around a given figure, around a figure. So you might have different types of figures, but perimeter remains to be the distance all around. And we know what is distance. Distance is simply length. It is length between 2 points. So anytime you're walking around or you're getting total distance around any figure, then it's the same as getting the perimeter of that figure. The units of measuring perimeter is simply the units of length. The units of length, and we know them because in our previous class we talked about the units of length, and this one, Kenya has dug many dams containing minerals. We know that this is kilometers, we have hectometers, we have decameters, we have meters, decimeters, we have centimeters, and we have millimeters. These are the major units of measuring length. So perimeter can be given in any of these units, either in kilometers, in hectometers, decameters, or even meters, decimeters, centimeters, or millimeters. These are the major units of measuring the perimeter of a figure. Now, we can have a number of examples here. If I try and open a number of examples here, I have this one. This is an example here. The question here is find the perimeter of each of the following figures. So you have a figure like this. This is a figure. It's a combination of a number of figures here, but perimeter is simply the distance around. So if I say that this one is maybe point A, if I give that one point A, I call this one point B. I call this one C. I call this one D. Here it is E. Here it is F, G, H, I, and J. If I want to get the perimeter of this figure, perimeter, I just begin from one point. Is the distance from A to B, then you have B to C, then C to D, then you have D to E, you have EF, you have FG, you have GH, then GH, this one is supposed to be I, then you have J, then going back to that. So if I want to get the perimeter of this figure, I just come and say perimeter, letter P here stands for perimeter, is the distance from A to B. I believe these units are in centimeters. So you take distance from A to B, and what is that? That is 4.3. I add from B to C, that is 1. I add from C to D, and here I need to have some calculations here. The distance here, if I extend, I put a dotted line here. If I put a dotted line here, the distance here from this particular point to this point is the same as this one. So this one is 1 centimeter. So you can see that if I want the distance from C to D, if from here from A to B is 4.3, and this one is already 1 centimeter. So this one makes, if I take 4.3, I subtract this one, I remain with 3.3. So I add 3.3, then I add the distance, this one is 1. I add from here up to here, that is 2. Then from F to G, that is 1. I add from G to H. G to H, I believe these two. From E to F, this one is E. They have E, E, F, and H, G. They are the same. So I add 2 centimeters. Then I add from here up to this mark. I can be able to get what is that distance, because if I extend this one, already this one is 1, this is 1 centimeter, this is 1 centimeter, this is 1 centimeter. So 1 centimeter plus 1, that is 2, plus another one, that is 3. So if I take 3, subtract the whole of this distance, so 5.3, I subtract 3, I'll get 2.3. Then I add this distance, which is 1. Then I add the distance from J to A, which is 5.3. So perimeter is simply the distance around a figure. And I want to take some time and add all this, and you tell me what is the answer. Take 4.3, you add 1 centimeter, you add 3.3, you add 1, you add 2, you add 1 again, you add 2 again, you add 2.3, you add 1 centimeter, and finally you add 5.3. What is your answer? Okay, my answer, if I work out that, it is 23.3 centimeters. So that is the distance around this figure. That is the perimeter around this figure. So even for other examples, like B, you have C, you have D, perimeter is the same, is the distance around a figure. If I pick another example from a different angle, if I pick another one like an example here, here we have a diagram, can have this one, or even you have another one of a different nature. Here you have the perimeter of a triangle, I'm looking at number 10. Find the perimeter of a triangle whose sides are x, 2x, and x minus 5. So let us try and have this one. So you have x, 2x, and x minus 5. How can I be able to get a perimeter of that? So this is an example, another example that I want us to look at it. They want me to get the perimeter of a triangle, a perimeter of a triangle. A triangle is a figure that has three sides. So perimeter of that. So one side is x, the other side is 2x, and the other one is x minus 5. Let me confirm that perimeter of x, 2x, and x minus 5. So they want me to get the perimeter of that. I will come and follow the same procedure. So if all these are perimeter, I want to get perimeter. I know that perimeter is distance around a figure. So I'll take, if this one is point A, this one is point B, and you have C here, perimeter is moving all around this figure. And if I'm given this one as from A to B is distance, the distance here is x. They have used a known here. I add distance from B to C, it is 2x. Then I add distance from C to A, that is the same as x minus 5. So what is perimeter here? Perimeter is just distance around this figure. I'll put the like terms together, and x, 2x, and x, they are like terms. So if I take x plus 2x, that will be 3x, then plus x, that will be 5x. I'll take 5x, I minus 5. And because 5x is unknown here, I'll leave my answer that way. So this one, it will be in centimeter according to the units that have been given there. So this is how we get the perimeter of a figure. Perimeter is just distance around a figure. We really don't have a specific formula, but this is the main thing. The total distance around a figure, total length around a figure, that is what will give me perimeter. The only thing you need to note here is that all the units for perimeter ought to be the same always. If you're using kilometers, you make sure that all the units are in kilometers. If it is hectometers or decameters, meters, you just ensure that the units are uniform, right? So this is the first part. The second part, it is circumference. I want us to talk about circumference, circumference of a circle, circumference of a circle. Now, circumference of a circle simply means is the distance, distance around a circle. Circumference of a circle is the distance around a circle. Now, what does that one mean? When I'm talking about distance around a circle looks like this. A circle is a figure that looks uh, like, like that. And we normally have, if this one is the center of the circle, we have a line that is passing through, a straight line that is joining the two parts. This line, we call it diameter. That is the name of that line. I'll call it capital D. Or even you can also draw a circle like this, and we have a line that is not touching the two parts of the circle, but just coming to the center like that. So this one is called radius. You are right that this one is radius. I'll use it capital R. Now, how do you get distance around a circle? We have a formula for that. That circumference of a circle, because it's a distance around a circle, is given by, so I write circumference of a circle. I'll use letter C to represent circumference, is the same as pi d. So C is equals to pi D, where this pi many times is always 22 all over 7. This one you're given is a constant value, 22 all over 7. Sometimes it can be given as a decimal, depending with the question. Or if you look at diameter and radius, you'll see that diameter is twice radius. Diameter is the same as you take a radius, then you multiply by 2. So the other formula of getting circumference or distance around a circle, circumference is same as 2 pi r. There is no square anywhere. This is radius. Can use capital R. So this one stands for radius. So circumference can either be given by pi d, or you can say circumference is the same as 2 pi r. If the question gives you diameter, then this is the easier one to use. But if the question gives you radius, then this one is the easier one to use. Let us have a number of examples here. If I pick an example for that, if I pick an example of perimeter of a circle, let me pick like this one. This one is about the area, but I can pick another one that has distance around a circle here. I'll pick one that is easier for us to relate with. Let me pick this one and just change one or two things about the area. Now, if I have a circle whose radius is 3.5, calculate the area of a circle. Now, this one is telling us to get the area, but I want to get the circumference of a circle. So if I have a circle that looks like this, I have a circle that looks like this. Example, we have a circle that looks like that. It needs to be a bit uniform. To draw mine to be uniform. Very good. So we have a radius of 3.5. So I want to get the distance around this circle. So if I begin here, what is the distance if I move all around this circle until I come back to the place where I started from? How do you get that? Now, if I'm given the radius, I'll come and apply. Either of the formulas is true, because if I'm given radius here, it means that diameter is the same as you take radius, which is 3.5, then you multiply by 2. If you take 3.5, you multiply by 2, the same as 7. This one is in centimeters, so I'll say 7 centimeters. So I can use whichever formula for me to get my answer. Therefore, if I'm given radius, I can come here and say circumference is 2 pi r. And what is my r? My r is 3.5. Okay, therefore, I'll come and say circumference is the same as, I follow the formula here, which was 2 pi r. I substitute these values. 2 here, I write here down. Pi, I write it is 22 all over 7, because you say that pi is a constant value that I've been given, 22 all over 7. Then I multiply by radius, which is 3.5. This is the same as 2. You multiply by 22 all over 7. You multiply by, this one I can change into decimal, into fraction, which is same as 35 all over 10. Then I simplify by 7 1 by 7 5, so that I can multiply this one out. 2 you multiply by 22, that is 44. Then I take 44, I multiply by 5. My answer is 220. Then 1 multiplied by 10 is same as 10. Then I can simplify by that 0, by that 0. My answer is 22 centimeters. So that is how we get the circumference of a circle. If I'm given radius, I can follow that. What if, this is example 1, what if I'm given maybe example 2, a circle. I want to get the circumference of a circle, and a circle maybe I've been given diameter instead of radius, and let me say maybe diameter is 21 meters, 21 meters here. So I'll do the same thing. Now that I've been given diameter, I'll come and apply the formula that has a diameter here. So I'll say that circumference is the same as pi d. And what is pi? Pi is, right, 22 all over 7. Then I multiply by, what is diameter from this circle? The same as 21. Then I simplify here by 7 1 by 7 3. 7 goes into 21 3 times. Therefore, you multiply 22 by 3, and your answer is the answer here is 66 meters. So you have your answer like that. So that is how you get the perimeter, or the distance around a circle, and which we've given it a name as the circumference of a circle. Right. I hope you are with me up to that. That perimeter is the distance around a figure. It doesn't matter how a figure looks like. It's just a distance all around. You make sure the units are the same, then you add them together. Circumference is the distance around specifically a circle, and we have a formula for that, and we've had a number of examples for that. Okay, the next thing, it is the length of an arc. Length of an arc. Now, let me rule my work here. Ensure that your work is clean enough so that you can be able to have a good revision. Ensure that you divide your book in a good way. Okay. Then length of an arc. So this is number 3. Length of an arc. Length of an arc. That is number 3. And before we even start, what is an arc? If I have a circle that looks like this, I have a circle that looks like that. Sorry for this. Let me clear this part. So you have a semicircle that is of that nature. Of course, then I cut into a piece like that. I cut this part. Maybe I call this one A, and I cut this part B. I'll end up having part, maybe this one is C, and this one I call it D. If I cut here, and I cut point B, I'll end up having something like this, where you have your C here, and you have your A here, and you have your B here, and even the other side, you have it. Maybe this one is our A, this one is my D, and this one is my B. Now, these lines that you're having here, these parts of the circumference or a full circle, is the one that you call them the arc or an arc. So arc is simply an arc. An arc is simply part of circumference. is part of circumference. So if you just cut any portion of circumference, then that one becomes an arc, ARC. So an arc is part of circumference. Now, if this one is bigger than this one, this ACB is bigger than that, the other one, then this one I call it major arc, and the other one is the opposite of that. I'll call it a minor arc. So a major arc is a part of circumference that is bigger than the other part. Minor is the smaller part. So an arc is part of circumference, part of circumference, part of circumference. Now, how do we get the length of an arc? How do we get the distance from A to B? Because now this one is not complete. Now, if I want to get the length of an arc, or sometimes I call it an arc length, arc length, length of an um, arc length is obtained by this formula. That if I have, we say that circumference, a full circle, circumference, the formula for getting that, can you remember how do you get circumference of a circle? Is given by pi d. Now, this one is for getting a full circle. But if you're getting a portion of it, because arc is just part of it, if you're getting part of a full circle, part of circumference, then it is theta all over 360. Then you multiply by the formula that we had before. I'll explain what is the meaning of this. Now, if I have a circle that was, maybe I have a circle that was initially like that, then and I cut into piece. Maybe I cut this section and I cut that section, and maybe the center of that it is that. So I end up having this part. I end up having this part. So we have that, and I have that part. Now, how do I get the length of this? Either this section. Now, this one is a smaller one, so I'll call it the minor arc. Then you have the major arc. You have the major arc, the other one, the other opposite side. How do we get that? Now, for me to be able to get that, this formula, this one that you have here, this one, you say that arc length, or the length of this arc, this one is what you're calling the arc, major arc. This one is also called an arc. So arc is the curved part. This is not an arc. This distance, if O from the center, that is not an arc. Arc is the curved part. So if I want to get that, I'll come and pick this theta here. This one I'm calling it theta. Theta is the angle that this arc extends or subtends at the center there. So the angle that you have here is the one that I'm calling it theta. So if I want to get the length of this arc, I'm getting the length of this arc. This one is a minor arc. The smaller one is a minor. The one is major. So if I want to get the length of this minor arc, I'll come and take the angle that is in between. Between these two radii here, the angle in between here, I'll take that. Then I divide by 360, then I multiply by pi, then diameter. And if I want to get for the major, the distance from this particular point all the way to this particular point. Then I'll take the angle that is on the opposite side. So this angle that you have there. So make sure you get this formula that arc length is the same as theta all over 360 then pi d. So this pi d is it was for a full circle, but now this one gives me the fraction of the circumference that you are having there. So we have an example for that. We have a number of examples. Let me pick one or two examples here. Then we see what that one means. Okay, let me start with this one. Find the perimeter of each of the following. If I pick maybe A, I pick A. So I have a diagram that is like this. A diagram that is, they want me to get the perimeter, and I have a circle that was initially like that. But now if this one is the center, so they have put a mark there. They have put a mark there. They are saying this one is 60 degrees. This one is 6 centimeters. 6 centimeters. So then this is not there. This is not there. It's not there. Okay. So let me extend this one. So they want me to get, this one is the center. Forgive me, this one is supposed to be a perfect circle, but you'll see, you've seen the question. Now, perimeter of this, it means that if I start from point O, then I move to this particular distance. This one is the radius, and we know that any distance from the center to the circumference is the radius. So this one is radius. And if this one is also radius, then this one is also 6 centimeters. So perimeter is distance around a figure. So I'll take 0, I add to this, then gives me the distance there, which is 6. Then I take this part. You see now, this one is not a complete circle. This origin is not a complete circle. And if it's not a complete circle, then it's not a circumference, because circumference refers to the distance all around a circle. It's supposed to be complete. But now this one is not complete. Therefore, I will, if it's just a portion of circumference, this one now becomes an arc. So the distance here, the perimeter, I'll come and add this radius here, which is 6. Then I add, this one is an arc length, the distance, the length of this arc. And you can see it's a major because it is something small that has been removed here. This one is a minor arc, this one is a major arc. So I add the arc length. Then that one will give me the distance all around up to this particular point. Then I add this one, which is the same as 6. All right. And now I know the formula of getting arc length. So I'll come and say that arc length, the length of an arc is given by angle all over 360. Then I multiply by pi d. Then I ask myself, what is the angle that this major arc extend at the center? Now this 60 is for this smaller one. So I need to get what is the angle all around, because this is outside here. It is not the angle that we are having here. This angle is for this, as the one that has been removed here. Okay, so I know that angles at a point, the whole of this angle at a point is supposed to be 360. But now if this one is 60, then it means the remaining part is the one that is the angle subtended by the major arc. So if I take 360, I minus this 60 here, my angle will be 300 degrees. So therefore, theta is 300 degrees. Then diameter you said is the same as you take the radius, then you multiply by 2. So I'll take radius which is 6. I take my radius which is 6, then I multiply by 2. And what is 6 multiplied by 2? The answer is 12 centimeters. Now I have everything here. I'll come and say that arc length from my formula is given by the angle, which is 300 all over 360. Then I multiply by pi, which is 22 all over 7. Then I multiply by diameter, which is 12. Now this one I just multiply the normal way. I can choose to simplify. If there is a number that I can simplify here, for example, I can simplify here by this 0, can go with that 0. And I think 6 can divide both 36 and even 30. So 6 goes into 36 how many times? 6 times. 6 goes into 30 how many times? 5 times. I can simplify 6 goes into 12. How many times? So it goes here 2 times. Then 6 goes into 6 how many times? 1 time. So do you have another number that you can simplify? The numerator and denominator? No. So I'll say 5. I've remained with 5 here. You multiply by 22, then you multiply by 2. Then denominator here, it is just 1 by 7. 1 you multiply by 7. And what is my answer here? You can multiply and we give our answer to 2 decimal places, or even you leave as a fraction. So 5 you multiply by 22, then you multiply by 2. The answer is 220 all over 7. So this one is the arc length in terms of improper fraction. Therefore, the total distance all around, if I move, so this distance here is 220 all over 7. So I'll take 6, I add 22 all over 220 all over 7, then I add 6 like that. So this one you can work it out to see what you'll get, because if I take 6, I add 220 all over 7, then I add 6. My answer will be 43, then 3 all over 7. I believe that is the answer that you're getting. You can use the method of getting the LCM. Because of time, I don't want to do every detail there, but you can follow through. Because you can get the LCM of all this, then you work it out. So that is how we get the length of an arc. Arc is part of circumference, and you get that. If I pick another example, example 2, let me pick another example from what we've seen there. I can pick another one. Let me pick from this wording. Let me pick from this. Find the radius of a bicycle wheel whose circumference is this one. Now, all right. For this one, it's I want to pick one that has a length. This one is a full circumference, so it's a full circle. Let me pick one that has an arc. Okay, an arc PQ of a circle of radius 15 centimeters represents an angle of 160 at the center of the circle. Find the length of an arc. Let me pick this one. An arc length PQ of a circle of radius 15 centimeter represents an angle of 160. So I'll come and draw that. It's always good to to draw. It helps you to imagine and make your work easier. So we have a circle here that is like that. Not a full circle. It is an arc. So we have an arc here. So I'll put mine maybe like that. That is not a full circle. So like that. Then they are saying that it has a radius of 15 centimeters and the angle at the center is 160 degrees. So they want me to get the arc length. Now arc length, if this one is P, this one is Q. Arc length is just part of this. Please get the difference between perimeter of this and the arc length. Arc length is just portion of circumference. So I'll not add this because this is not part of an arc. So I'll come and say that arc length or length of an arc is the same as the angle at the center, then you multiply by pi d. Then I come and ask myself, what is the angle at the center? If you look at this, the angle is 100 and what? 60. Then I divide by 360. Then I multiply by, what is pi? Pi is 12 over 7. Then what is diameter? If radius is 15, then diameter you just multiply by 2 and you get your answer as 30. Then now you work it out. I think this 0 can go with this 0. Then by 3, 1, by 3, 12. Then I can also simplify here to see what I will have. By 4, you're having 3. And by 4, here you have 40. So you end up remaining with the sum here. It is, let me push this one slightly so that we have a space here. So I remain with 40. This is the same as 40. I multiply by 22. You multiply by 1. So this one has been simplified all over. 3, I multiply by 7. So what is your answer? 40 you multiply by 22, this is 880. Then 23, this 3 you multiply by 7, that is 21. So if you take 280, you simplify, you're dividing by divide by 21, your answer is supposed to be, I can write as a decimal. Can come here and write as a decimal, and my answer will be 13, then a recurring, so 13.333 centimeters. If the units here are in centimeters, so I have 13.3333. Let me write properly. 13.33 centimeters. So that is how we get the length of an arc. That is how we get the length of an arc. All right. So we have that one. We'll have more examples later for that. Okay. Now, after talking about that, make sure you check what is happening here. We'll have more examples. I think I can give you a number of, from what you've done, you can try the following. You can try a number of examples here. So we've done perimeter. So I can give some assignment here. I want you to attempt, as part of exercise, I want you to attempt number B, this diagram. All these measurements are in centimeters. So attempt number B, attempt this one. Also attempt this one. I want you to think about this. I want you to attempt this one. How do you get the perimeter of this? So those are two questions. Also, attempt one here. A rectangular. You can attempt number 6. You tell me what is the perimeter of this. So you attempt number 6. And those are 3 questions. I can pick one of a circle. We pick one or two here of a circle, especially the arc length. So here I want you to pick this one, and you can. This is the same as half of a circle. So get for me the perimeter, and be keen here. The question is the perimeter. You can also attempt this one, number C, like that. Then we pick one of a full circle, number 6 here. You attempt this, and also number 8. You attempt that. So we have attempt B, C, number 6, and also number 8. Thank you so much for your time. Ensure you do it and make sure you write your answer clearly. Also be glad to get your feedback in the comment section.